so this is Causal Inference in Statistics, that book right there. And we're on the second to last question of the entire book. So we're in section, or chapter 4, and we're on question 4.53. And again, all of chapter 4 is dealing with counterfactuals and different things you can do with counterfactuals. And one of the first things that we did in the first part of the chapter was to look at these probabilities of necessity, of sufficiency, and so forth. And in the second part of the chapter, we have been dealing with mediation. And we've done quite a bit of work building up mediation. And this playlist here goes into depth for some of the examples presented in the book. And the reason we did that was because I think that maybe the topic is sufficiently difficult, and the authors, in trying to make the book accessible, kind of skipped over some things. So hopefully you've watched those videos. Now here in question 4.5.3, it's similar to the previous one, 4.52, which looked like this, where we had a model that looked like this, but we have a slightly more complicated model here. Okay, so we have a model now that looks like this. That now has a term for W, and W is in the mix here. Okay, so we are meant to consider this model where this little term right here represents an interaction term. Okay, and we've dealt with interaction terms above, or sometimes called a variable specific effect, maybe an M specific effect in this case. And so we are going to use the basic definitions of some of the natural effects, natural direct effect, natural indirect effect, etc., which we discussed earlier, way up here. So you can watch those videos if you'd like. And we are, wrong one. And we are going to try to find expressions for the NDE, the NIE, etc., etc., etc. And at the conclusion, we should come up with for part A these expressions for for the respective terms on the left-hand side. Okay. Now, well, I guess I'll get to B here, part B here in a second. But when you do, or when you try to implement these in a DAG, to the best of my understanding, it looks something like this. So we have a treatment T, and it's affecting the outcome. Here it's, I guess, just that should be Y. Yeah, Y. And then T is acting through both W and M, and W is affecting M. Okay, so hopefully you can kind of maybe build that DAG for yourself. Often, when there are interaction terms, some people will, I think, shy away from using DAGs because interactions themselves are not easy to represent in a DAG. In fact, I don't know that I've actually seen a good way of doing it. I mean, there's a couple of ways of doing it. But that's why we often work both with the structural model and the DAG. So in part A, we are just assuming that M is the mediator. And then in part B, we assume that W is the mediator. Okay, but notice that there's actually two mediators here, T to W to Y, T to M to Y. Okay, so we're going to do both. All right. So just starting with part A, so I just told you that we're going to use M as the mediator and then W. But when I was first doing this, it was unclear to me which we were supposed to use as the mediator, because both M and W are mediators. Okay, and so I first set about solving for the NDE with using an additional term for the W. Okay, and so for NDE, remember this is the effect of changing the treatment from 1 to 0, and then fixing the mediator, or in this case mediators, to the value they would obtain when treatment was 0. And so again, you can go through this math. By this point, you have seen kind of this counterfactual calculus that we've developed. Okay, And when you push all of that through, you get beta 2. Well, this is not the NDE that we are supposed to find. So that told me that we are not supposed to use W and M both as mediators. So when we just use one, M naught, or M in this case, okay, we in fact come out with the right expression. Again, I'm not going to step through all of the math here, so hopefully you can either follow how the math is working, or you've seen the previous videos in the playlist. Okay. Okay, and so now that I know that the question means, just use M and not W as the mediator, we get the NIE, okay, right here. And again, the NIE is the natural indirect effect, and this is the effect on the outcome when we hold the treatment at its null value and then allow the mediator to vary from the value it would obtain when treatment was 1 and treatment was 0. Okay. And so again, you can march through that math there. And then for the total effect, this is just the expected value of y, or the expected difference of y, when we allow treatment to go from 1 to 0, discarding any of the mediators, or I shouldn't say discarding them, allowing them to vary as they would when treatment equals 1 and treatment equals 0. Okay. And so again, you can march through all of that math there. And then finally, we're supposed to show that the total effect minus the natural direct effect equals this, which is just very basic, because here's the expression for total effect, and here's the expression for natural direct effect. And you see that they just work perfect. Okay, so now we're supposed to do this again, but now, instead of using M as the mediator, we use W as the sole mediator. Okay, and this time we are not given answers. Okay, and so hopefully I didn't make a mistake. If you catch one, please let me know. But we go through and we get predictably different answers for each of these compared to the M as a mediator version, okay, for both the natural direct effect and the natural indirect effect, okay. And this should make sense because when we look at our DAG, here, we are we're activating or fixing different pathways stemming off of T here, okay, or the mediators, and so we should get different values or different answers between the two, except for the total effect. Why? Because again, the total effect just allows these mediators to vary as they would, right? So we get the same answer for the total effect between the two. Okay, and again, TE minus NDE, this is just simple arithmetic, and we get an expression like this. Okay. Now finally, I went ahead because I went ahead and tried to figure out what these answers would be if you didn't arbitrarily pick one of these as a mediator and said they're both mediators. So we already saw that for my first attempt at the NDE, but I also go through and do it for the NIE and the total effect and so on. So let me get back down here. So we already did for the NDE. Okay. For the NIE, I allow M and W to vary in the same way. So in other words, they both obtain their 1 value and their 0 value at the same time. Okay. I suppose that you could come up with, like with this counterfactual calculus here, as I'm calling it, you could come up with all sorts of kind of crazy combinations of these different variables and pump out an appropriate answer here. But the NIE for this situation, rounds out right here. Okay. Now, what is interesting about this NIE term, okay, is that let's go up here. So let's look at this DAG here. If I want to know the natural direct effect after using both W and M as mediators, that would mean that I'm fixing both W and M to some value. So in other words, I'm blocking both mediating pathways. Okay? And so what would I expect to be the natural direct effect of treatment? Well, it would just be this green arrow right here, of course, right? And that's beta, whatever it was. You know, it was the beta 2, okay? Because these other two variables are being held constant, okay? Now, when I found my natural indirect effect for M and W, you know, we're picking up pathways like from T to M, some different pathways, but without like trying to diagram it all out. One thing that you might think is that the natural indirect effect for when we use both M and W as mediators, well, maybe it's the sum of their natural indirect effects, right? So in other words, maybe it's the sum of the natural indirect effect for M as well as for W, okay? But that's not quite right, okay? And the reason that it's not quite right is because you can imagine that if we were to do that, we would be duplicating some of these pathways, right? So if I jiggle T, you know, if I vary T or whatever, and I want to find the natural indirect effect, you know, that jiggling of T reverberates in M and W, and you know, then ultimately to Y. But some of that, if I were to just consider one of the mediators, some of that jiggling would be the same jiggling that would take place as if I held the other mediators constant. Okay, so in other words, we're duplicating pathways. And so it doesn't seem then that the sum of natural indirect effects would be correct. But you know what would be correct is the unique pathways using both of these mediators. So if I were to analyze the indirect effects of both mediators independently, maybe it is the unique pathways that would be jiggled in either analysis. In other words, the union between the two. Okay, and so when you go through and you calculate this, so the NIE comes out to this guy right here, and in fact, what we get is that value right there, okay, equals in fact the union of the two other natural indirect effects. And so to see that, I'm just going to expand the answer that we got there. So we get this. Okay, and so we see all of the terms. And so notice that the answer that we got for using both mediators was every unique term from the other two natural indirect effects, which is a gratifying result, right? So we see beta 1, gamma 1. Here's beta 1, gamma 1. Okay, and where did that come from? Well, that came from from NIE sub M, I'm calling it. And then we see, let me skip that one, beta 4 alpha. Okay, well, we see that comes from the NIE sub W. And then we see that beta 1 gamma 1 or beta 1 gamma 2 alpha is represented in both of the NIEs for M and W. And so we don't want to count that twice. And so the union, the union is the thing that gets captured when we use both as mediators, which again is very gratifying. Okay, and then we get the total effect. Again, this is the same as it ever was, okay, because we're allowing all of the mediators to vary as they would as treatment varies. Okay, so we get the same answer. And then finally, we can find the TE minus NDE, and we get this expression right here. Okay, so we have one more video to make, and that will conclude all of the questions for this book.